Welcome to our first discussion in chemistry. Today we're going to talk a lot about the periodic table of elements. Now, I will have some paper copies for you to look at when you're here. At home, you probably want something a little more spectacular than a black and white and gray representation of this thing. So I went to a website called dogpile.com. They have an images portion of that website. I typed in periodic table of elements and they give you a whole bunch of them. I looked at them, and the one that I'm going to be using the most, that is the most important to us of all those, and there's some pretty sharp ones, is this one right here. It looks like this. And it's cloudfront.net is the website that it comes from. So you may want to take a look at this. You'll notice that it's got a lot of pretty colors, pretty spectacular stuff. The colors aren't important. What we are going to be using it for is the set of numbers that we have at the top of each column. We're not going to use it in this discussion. We will later on in this chapter. What you are going to need to know is a list of some of the elements that we have here. Not every one of them. There's some pretty obscure ones here. And all these down here, the green elements are the man-made elements. They're not naturally found. They've been made in labs. So there's a couple of them that I want you to know, but for the most part, it's going to come from this main section up here, and a couple of them in this row right here. But I will give you a sheet with that. Now, let's talk about that. So like I said, you don't need to know the symbol and name of every element. The list I give to you is the one that you need to focus on before you come back to see me. On the list will be an asterisk by the elements in which the name and the symbol do not match. And you'll notice in the periodic chart, here, let's take an example. Here's element number 79, it's gold. Gold has the symbol of AU. Now, why does it have AU, not G or GO? And please notice, all these symbols have capital letters to begin with, and there's a second letter that's lowercase. So you must write your element symbols that way. But why does gold have capital A, little u? Well, it turns out that the first time gold was really identified semi-scientifically was in the days of Rome. And the language of the Romans was called Latin. And the Latin word for gold is aurum, A-U-R-U-M. And it kind of sticks with us today, because if somebody has like an aura about them, you'll hear that expression from time to time. Oh, she has such an aura about her. What they're saying is it's kind of like a golden glow, almost a form of reverence they have for that person. Well, like I said, the Latin word for gold is aurum, and that's what the aural refers to. And so, like silver is another one, iron is another one, antimony or antimony, depending on what part of the world you live in, as SB. There's a lot of bizarre ones here, but not unmanageable. But like I said, the sheet will identify them. The example of where they kind of match up, but there's some inconsistencies in there, or it doesn't make sense why they gave them the letters they did. The best example of that is Ra, which is radium, over here in column 2, and over here in column 18 or 8A is Rn. That's radon. They both begin with Ra. So an organization called the International Union for Pure and Applied Chemistry decided arbitrarily, for no particular reason that I can think of, to give the Ra to radium and the Rn to the radon. Radon is a gas, radium is a solid. Maybe that's why, I really don't know. But the IUPAC is constantly coming up with names for elements and compounds, and all kinds of things chemistry related, and they don't necessarily have a good reason, they just feel it's the best thing for them. So this is your basis right here for your first lesson. Okay. And like I said, you're going to get this sheet as well as the listing sheet for your perusal as we go through this. You do not need to know any of the numbers associated with those elements. So all those numbers I was spouting at you, you don't need to know. As we go along in this chapter, we will go into details as to what we can predict about the layout of the elements of the chart. That comes later on. That'll be the next week when we get into that stuff. So let's just talk about what we are actually dealing with. The first chapter, the first of at least 6 that we are going to be doing in the semester, deals with the study of matter. Now that is actually the definition of chemistry. Now, I'm not the kind of person that's going to ask that you memorize definitions. That's just regurgitation of facts, and that means nothing to me. What's important to me is your understanding of the facts and being able to go beyond that, go into the more complex thinking skills. That's my job, is to turn you into the best thinkers you can possibly be. I'm going to make you so much smarter than you ever thought you could be, just by this course alone. And if you decide to go on to other classes that I'm going to be teaching in science, it's going to get better. But I'm going to challenge you. But I'm not going to ask you to memorize, okay? Now, unless it's important, like, I don't know, the periodic table, you do need to know those elements. But there's going to be some formulas, but most of those things are going to make sense as to where they came from. And so there'll be a certain amount of logic behind that, okay? So, matter. Matter is defined as anything that has mass and takes in space that are known as volume. Matter is divided into 2 categories, pure substances and mixtures. This is an example of matter. This trash can definitely has mass. It's kind of heavy, not real heavy, but because I'm manly, but also has a lot of volume. Air is matter. Well, how do you know air has mass? Well, the way you find out is if you fill a balloon up with helium and then let it go. Why does it go? Why does it just drop to the ground like a trash can? Well, you say it's lighter than air. What does that mean? It's actually may not be lighter than air at a particular moment in time, but it turns out that its density is less, and density is one of the things that we're going to talk about in the next chapter, that mathematical relationship between mass and volume, which I'm sure we've dealt with before, but we're going to get into it, like I said, at the end of the next chapter. But the fact that it goes up means that air has to have mass. And another good way of knowing that air has mass is by going up into a plane and looking down at the ground as you get up a couple of thousand feet in the air. You should notice that the air below you is gray or brownish kind of color, where it's very transparent above. You can't see any particles floating around, but you see the pollution spread out in a heavy dose down below. And the bigger the city, generally, the greater the mass of what they call particulate matter, which is what pollution is. So, that's another way of knowing that we have mass. So, we're going to talk about the pure substances subcategory elements. Now we have 2 categories, like I said, pure substances and mixtures, and then subcategories, meaning that they are categories of the categories. Okay? So, elements cannot be broken down by traditional means. And what I mean by traditional or common means is that we can't go to the lab and I say, okay, here's an iron atom, split it. Not possible. Not with our equipment. I mean, it is possible to do it with some equipment, but it takes millions of dollars of values of machines doing this stuff, and I'm lucky if I can get a $5 machine in there. So we're not going to be able to do that. But all elements are found in that periodic table. There's no exception. Your first task will be to know the names and the symbols of the elements in the list that I give you. You'll get at least one quiz, probably more, depending upon the scenario. You have 6 elements. I'll give you 3 names and 3 symbols. You give me the correct symbol for the names, and you give me the correct spelling of the elements of those symbols. If you get them all right, you are done. You can go on to the next section. Also, I'm going to have labs back there in the lab, little mini labs for you to take a look at as we get into that part of the chapter. So like if you get done with everything, you'll be able to go back to the lab and get a little extra work and understanding as to what the heck I'm talking about up here. Okay? So this week is just going to be kind of a smattering of a couple of things that we're going to get into, and then we'll get into it much more heavily in the next week. Okay? Look forward to meeting you guys, and we'll talk to you later.